Let's go over some of our rules of derivation. First, let's start with the derivative of a constant. Suppose you have a function f, and function f is a constant k. In other words, for any value of x, f will always be k. What is the derivative of f? In this case, we can take the limit of f at x plus delta x minus f at x and divide it by delta x. Of course, f at x plus delta x is simply k, and f at x is also k, so k minus k equals 0. It follows that the derivative of a constant is 0. Now let's look at the sum rule. Let's define a function h as equal to the sum of two other functions f and g, both of which depend on x. What if we want to find the derivative of h with respect to x? Well, one beautiful thing about operators is that they can be treated almost as variables. In other words, some of the basic rules like factoring can function on operators as well. In this case, the derivative with respect to x of f plus g is equal to the derivative of f plus the derivative of g. For example, let's define a function h as x squared plus cosine of x. What is the derivative of h with respect to x? In this case, using the sum rule and taking x squared to be our function f and cosine x to be our function g, we get that the derivative of h is equal to 2x minus sine of x. Now let's look at the product rule. Suppose we have a function h which is equal to f times g, where f and g are both functions of x. What does the derivative of h with respect to x look like? In this case, we'll be looking at the derivative with respect to x of f times g. Now this one is not as intuitive as the previous one. However, the rule is pretty easy to remember. In this case, the result will be the derivative of f times g plus f times the derivative of g. This product rule will be very useful in your fluid mechanics course. As an example, let's prove that constant rule that we introduced in our previous video. We said that the derivative of kf, where k is a constant and f is a function, is equal to k times the derivative of f. We can figure this out by using the product rule, which tells us that the derivative of kf is equal to f times the derivative of k plus k times the derivative of f. Now the constant rule tells us that the derivative of k equals 0 because k is a constant. And therefore we show that the derivative of k, f, is equal to k times the derivative of f. Finally, let's look at the chain rule. In this case, let's define a function h. H is equal to f, which itself is a function of g, which itself is a function of x. What does the derivative of h with respect to x look like? In this case, the chain rule tells us that dh over dx will equal df over dg times dg over dx. The chain rule will become very important when we're looking at velocity and acceleration. For example, let's show that the derivative of f over g, where f and g are both functions of x, is equal to g times the derivative of f minus f times the derivative of g divided by g squared. In this case, our function h is simply f over g, where f and g are both functions of x. And the derivative of h with respect to x is equal to the derivative with respect to x of f over g. Now we can actually express this in a different way so that we can apply the product rule to it. Let's define a function j, which will be equal to g to the power of -1, or simply 1 over g. In this case, j is also a function of x. We can express dh over dx as the derivative with respect to x of f times j, where j, remember, is just 1 over g. Now the product rule tells us that dh over dx will be equal to j times df dx plus f times dj dx. Following the chain rule, we see that the derivative of j with respect to x is equal to the derivative of j with respect to g times the derivative of g with respect to x. And of course, the derivative of j with respect to g is simply the derivative of g to the power of -1 with respect to g. This gives us negative g to the power of -2 times dg over dx. Finally, we're left with dh over dx equal to j, which is actually just 1 over g, times df over dx, minus 1 over g squared times f times dg over dx. With a little bit of manipulation, we end up with g times df over dx minus f times dg over dx over g squared. And this is actually known as the quotient rule, and it's the last rule that we'll cover in this video.